3.2. The mean value of a function. You can find the mean value of a finite set of values by adding them up and dividing by the number of values. So, if we've got values y1, y2, y3, all the way up to yn, and we add those together and divide by the number of values n, you can see the mean of y is shown by this. And that's just standard results, isn't it? But you can extend this definition to evaluate the mean value, or sometimes called the average value, of a function on a given interval a, b. Now, in this case, the function takes an infinite number of values, so you want to represent their sum by integrating the function between a and b, and you represent the number of values by the width of the interval b minus a. So the mean value of a function f of x over the interval a to b, that's given by 1 over b minus a times by the integral of f of x with respect to x from a to b. And let's take a look at the reason why that is. You can think of the mean value geometrically by considering the area A bounded by the curve y equals f of x, the x-axis and the lines x equals a and x equals b. And you see that shown in green over here. We've got our function f of x and the area in between the x-axis, the lines x equals a, x equals b, and under the curve, that's shown in green. And if you were to draw a rectangle with its base on the interval a to b, so we've got a rectangle shown in blue. The base here is b minus a. The height of this rectangle is f bar. Then the area of the rectangle would be equal to a. So the area of the rectangle, that's b minus a times by f, and if we set this equal to the area under the curve, we end up with this result here. b minus a times by f bar, this is the area of the rectangle that's shown in blue. This is equal to the integral of f of x with respect to x from a to b, that's shown in green. And if we rearrange for f bar, that's equal to 1 over b minus a times by the integral from a to b of f of x with respect to x. This is the mean value of a function f of x over the interval a to b. We have to find the mean value of f of x equals 4 over the square root of 2 plus 3x over this interval from 2 to 6. And we have to use this idea over here to help us find the mean value of f of x over this particular interval. So if we match everything up as we see over here, you can see we've got over here 1 over 6 minus 2 times the integral from 2 to 6 of 4 over 2 plus 3x square rooted with respect to x. So all I've just done over here is match this result with the information given in the question. So if we work all of this out, you can see here we've got 1 over 6 minus 2, so that's the 1/4. And then we multiply this by this integral from 2 to 6 of 4 lots of 2 plus 3x to the power of minus 1/2. 1/4 times by 4, that's just 1. So we've got the integral from 2 to 6 of 2 plus 3x to the minus 1/2 with respect to x. Okay, so hopefully all this makes sense so far. Now, if we use the reverse chain rule to help us integrate this, if we add 1 to the power, we get 2 plus 3x to the power of 1/2. We then divide by the new power, which is 1/2. We divide by the differential of the bracket, which is 3. And then we will evaluate this from 2 to 6. So, you can see here, 1 divided by 3/2, that's 2/3. So we have over here 2/3 times by 2 plus 3x to the power of 1/2 from 2 to 6. Now if we substitute in our limits, for the upper limit, we've got 2/3 lots of 2 plus 3 times by 6 to the power of 1/2. For our lower limit, we've got 2/3 times by 2 plus 3 times by 2 to the power of 1/2. So if we work this out, well, we've got 2 plus 18, which is 20. So we've got 2/3 times by the square root of 20. And then we subtract off 2/3 times by, well, here we've got 6 plus 2, which is 8. So we subtract off 2/3 root 8. And now if we simplify all of this, we have 2/3 lots of root 20, which is the same as 2 root 5, and root 8, that's the same as 2 root 2. And if we take this 2 outside, you can see we've got 2 times by 2/3 times by root 5 minus root 2. It turns out all of this simplifies to 4/3 times by the square root of 5 minus the square root of 2. So that is the mean value over this particular interval. Number 5. We're given f of x equals 4/1 plus e to the x, and we have to show that the mean value of f of x over the interval natural log of 2 to natural log of 6 is equal to 4 times the natural log of 9/7 divided by the natural log of 3. Well, first of all, let's consider this integral from natural log 2 to natural log 6. So for part A, if we consider the integral from natural log 2 to natural log 6 of 4/1 plus e to the power of x with respect to x, we can use integration by substitution to help us do this. So to do this, we will let u equal e to the power of x, and therefore du over dx, that's equal to e to the power of x. And therefore dx, that's equal to du over u. When x is equal to the natural log of 2, we have u, which is equal to e to the power of the natural log of 2, which is just 2. When x is equal to the natural log of 6, u is equal to e to the natural log of 6, which is equal to 6. Now, what we can therefore say is the integral from natural log 2 to natural log 6 of 4/1 plus e to the x with respect to x. Now that we know our limits in terms of u, you can see here this is equal to the integral from 2 to 6 of 4 over 1 plus u lots of dx, which is 1 over u du. Okay, and if we tidy this up even more, hopefully here you can see this is the same as 4 lots of the integral from 2 to 6 of 1 over u lots of 1 plus u du. To integrate this, of course, we need to use partial fractions. So using partial fractions, what we have over here is 1 over u lots of 1 plus u, that's equal to a over u plus b over 1 plus u. So we've got 1 which is equal to a lots of 1 plus u plus b lots of u. You can see when u is equal to 0, we've got 1 equals a lots of 1, so therefore a is equal to 1. And you can see when u is equal to minus 1, we've got 1 equals b lots of minus 1, so therefore b equals minus 1. Knowing the values of a and b, we can therefore conclude that 1 over u lots of 1 plus u, that's equivalent to a over u, so here we've got 1 over u minus 1 over 1 plus u. So what we will now do is integrate. So if we use the result we have over here and replace as necessary, you can see over here that the integral of 4 lots of the integral from 2 to 6 of 1 over u lots of 1 plus u with respect to u, that's equal to 4 lots of the integral from 2 to 6 of 1 over u minus 1 over 1 plus u du. So we've got 4 lots of natural log u minus natural log 1 plus u from 2 to 6. And now if we substitute as necessary for our limits, well, what we'll do first is combine these logs. So here we've got the natural log of the mod of u over 1 plus u from 2 to 6. So therefore for our upper limit, we've got 4 lots of natural log of 6 over 1 plus 6. For lower limit, we've got 4 lots of natural log of 2 over 1 plus 2. Okay. So what we have over here is 4 times by the natural log of 6 over 7 minus 4 times by the natural log of 2 over 3. So if we factorize out the 4, we've got 4 lots of the natural log of 6 over 7 minus the natural log of 2/3. So here we've got 4 times by the natural log of 6 over 7 over 2/3. So our job is to tidy all this up, and if we tidy all this up, hopefully here you can see we end up with 9 over 7. So here we've got 4 times by the natural log of 9 over 7. So with this we can find out the mean value. Okay, so let's just write this down. Therefore, the mean value of f on the interval natural log 2 to natural log 6, this is equal to 1 over natural log 6 minus natural log 2 times by 4 times by the natural log of 9 over 7. So here we've got 1 over natural log of 6 over 2, so I'm just combining the logs. And then we times this by 4 times by the natural log of 9 over 7. So here we've got 4 times by the natural log of 9 over 7 over natural log of 3. And that's exactly what we wanted to show. For the question, it says use the answer to part A to find the mean value of the interval from natural log 2 to natural log 6 of f of x plus 4. So what we're doing over here then, in this question, is we're integrating from natural log 2 to natural log 6, 4 over 1 plus e to the x plus 4. And we're integrating all this with respect to x. Okay, because it says over here in the question, we're finding the mean value over this interval. So I'm going to calculate the integral of this bit and then find the mean value over it. So if we separate this, we've got the natural log of 2 to the natural log of 6 of 4 over 1 plus e to the x with respect to x plus the integral from natural log 2 to natural log 6 of 4 with respect to x. Now this result over here we've just worked out. We've just found this result over here to be 4 times by the natural log of 9 over 7. And then we add on this result over here. So we're going to add on 4x from natural log 2 to natural log 6. So if we work all of this out, we've got 4 times by the natural log of 9 over 7 plus 4 times by the natural log of 6 minus 4 times by the natural log of 2. So here we've got 4 times by the natural log of 9 over 7 plus 4 lots of the natural log over 6 over 2. So you can see here we've got 4 times by the natural log of 9 over 7 plus 4 times by the natural log of 3. So therefore, if we were to find out the mean value that's equal to 1 over the natural log of 6 minus the natural log of 2 of this result over here. So this result, we've got the natural log of 2 to natural log of 6 of 4 over 1 plus e to the x plus 4 with respect to x. So here we've got the natural log of 1 over the natural log of 3 times by 4 times by the natural log of 9 over 7 plus 4 times by the natural log of 3. So now we need to simplify all of this. So if we were to simplify all this, you can see here we've got 4 times by the natural log of 9 over 7 over the natural log of 3 plus 4 times by the natural log of 3 over the natural log of 3, which is equal to 4 times by the natural log of 9 over 7 over the natural log of 3 plus 4. So that is our final answer. Now for part C, we have to consider geometric considerations to write down the mean value of minus f of x over the interval from natural log of 2 to natural log of 6. So what you can see is minus f of x is a reflection in the x-axis of f of x. That's stuff you've met in A-level maths. So the mean value of f of x over this particular interval was 4 times natural log of 9 over 7 over natural log of 3. So therefore the mean value of minus f of x over this interval is minus 4 times natural log of 9 over 7 over natural log of 3. Now, in this example which we've just seen, you saw that geometric considerations can be used to find mean values of transformed functions if you already know the mean value of the original function on the same interval. So if the function f of x has mean value f bar over the interval a to b and k is a real constant, then f of x plus k has mean value f bar plus k over the interval a to b. K lots of f of x has mean value k times by f bar over the interval a to b, and minus f of x has mean value of minus f bar over the interval a to b. And you cannot deduce the mean value of f of minus x or f of kx in this way. And that's because we're dealing with values in the x direction.